So it's very important to know that everything we've done so far with area under the curve is integrals. An integral is the area under the curve. The integral symbol is this. It's a little swoopy. It's like swoop, right? So anytime you see this symbol, you know that you're doing an integral. The notation for it is this integral f of x dx. They write a dx here at the end, just for funsies, but it has to be here always. So whenever you see an integral, most of the time you're going to see it with numbers. This is called a definite integral, right? So let's say it's from like 0 to 8. This means the area under the curve from 0 to 8. So if I have a graph and it looks like this, and 8 is here, if I say find the integral of 0 to 8 of f of x dx, you know that you're finding all of this shaded region, right? You can find trapezoidal area, trapezoidal sum, left Riemann sum, right Riemann sum, midpoint Riemann sum. Those are all going to give you estimates of the integral of 0 to 8. It's also important to know that the bottom number always goes on the bottom and the larger number goes on top, right? That is because if you write it backwards and you go from 8 to 0, f of x dx, that means that whatever solution you get is backwards. So let's say that you have a function and it's a perfectly straight line that goes like this. And this is 12, right? And let's say this is 10. If you have to find the integral of this function, let's call it g of x, from 0 to 12, you would find, okay, it's a perfect triangle. So 12 times 10 is 120 divided by 2. The area is 60, right? 60 square units. So your integral here equals 60. If you wrote it backwards and said you're finding an integral from 12 to 0 of g of x, now it's the opposite. So what's that mean? It's backwards. All you have to know is that anytime the numbers are flipped, whatever your answer is, it's just going to be negative. So it's just negative 60. So this is the same thing as just putting a negative sign here, is if you flip the numbers. A couple more things that are important to know is that if you have an integral, let's say 8 is like around here. If you have the integral from 0 to 8, f of x dx, and then you also have the integral of 8 to 12 of f of x dx, right? 0 to 8 is going to be this region here, and 8 to 12 is going to be this region here, right? So if you add them up, it's the same thing as just saying 0 to 12. So anytime you have any situation like this where it's like 0 to 8 and then 8 to 12, or 0 to some number, or in calculus terms, if you add a to b and then b to c, this is the same thing as just the integral from a to c, right? It's the same thing as from the very first point to the very last point if they're all together. Also, I'm just going to speed through all the rules real quick. If you have like from 0 to 12 and you have 2 f of x dx, what do you do here, right? Do you multiply this function by 2 and make it like up here or something? No, you don't. You could just move the 2 to the outside. And this is the same thing as 2 of the integral from 0 to 12 f of x dx, right? So you just find this area, which is 60, we already said that, and multiply by 2, so this would just be 120. So anytime you have a constant inside, you just move it outside and multiply it at the end. Last thing, if you have an integral, let's say from 7 to 12, right? And let's say there's two functions. Let's say there's f of x and there's g of x, and they're added together. What do you do here? Do you add the two functions together first and then do it? No, you don't. This is the same exact thing as the integral from 7 to 12 of f of x plus the integral from 7 to 12 of g of x. So you're going to want to integrate them both separately and then add them together. And again, integrals is the same thing we've been doing with area under the curve, dividing it up into shapes. And if you can't do that, then using Riemann sums. So up right now, I have some integral practice problems. So let's try and solve these. So given that the integral from -2 to 1 of f of x is 6, from 1 to 5 is -5, and from -2 to 1 of g of x is a different function is 4, find the following. So the integral from 5 to 1, right? So the integral from 5 to 1 of f of x, what does this mean? We know our integral from 1 to 5 is -5, but 5 to 1 means you're doing it backwards, right? So it's just flipped. This is the same thing as a negative integral from 1 to 5 f of x dx, which we already know is -5. So if we have -5, we just end up with 5. All right, next one. We have the integral from -2 to 5. So what does this mean, right? So let's say our f of x function looks like this, right? And our axis is somewhere here, right? We know that from -2 to 1, the area is 6, right? And we know that from 1 to 5, the area is -5, so it's going to be down here. So if we add up all the area together, all we have to do is take our first area and subtract our second area to find the total, right? Because we're just adding them together. So we're adding 6 to this -5 over here. So 6 minus 5. So our area is going to be 1, or our integral for this is going to be 1. C here is getting a little bit harder. We have from -2 to 1 of f of x plus 2g of x. So like I said before, when you're adding two things together in an integral, you take the integral of each. So you have -2 to 1 f of x dx plus, and then the second part is the integral from -2 to 1 of 2g of x, right? But since it's multiplied by a constant, we can move the g of x to the front and just have 2 times the integral of -2 to 1 g of x dx. And now that we have what they are, we just substitute it. So -2 to 1, you just have 6. And for g of x, you have 4. So you have 2 times 4. So you have 6 plus 8. You're left with 14. And let's say we have a problem like this where it says go from 0 to 1. So what information do we have here that could help? We know that from -2 to 1 is 6, right? That's cool. But we don't know how that looks, right? We don't know how that looks from 0 to 1. All we know is in between -2 and 1, there's an area of 6. So this we just can't find, right? You just write can't find, can't determine anything. Next problem here, we have 3 f of x dx from 1 to -2. So we're doing a lot of things here. First, it's the bigger number on bottom, right? So it's flipped. So whatever our answer is going to be negative. Next up, we see this 3 here, so we can move that to the outside. So this is the same thing as writing -3, and then since we put the negative here, we could flip these back. And we could say -2 to 1 f of x dx, right? And we know that -2 to 1 is 6, and 6 times this -3 here, it's going to be -18. And our last problem here, we have from 5 to 5, f of x minus g of x. So from 5 to 5, what does that mean, right? It means from 1 point to 1 point, right? So if we have from 5 to 5, that means we're looking at from 1 point to 1 point, what the area is. That doesn't exist, right? Because it's 5 to 5. So anytime you see something that's just the same number twice on an integral, it's the same thing as just 0. So that's it for the basics of integrals and what they are. And next thing I'm going to cover is how to find actual integrals, not estimates, how to find actual integrals using calculus. So we moving on.